As an indicator of sympathetic nervous system activity and one of the most popular response systems in psychophysiology, electrodermal activity or EDA has become a widely used way of operationalizing various psychological constructs, including arousal, attention, and stress. The potential offered by EDA has not gone unnoticed by the SIGCHI community. Its low-cost, relatively unobtrusive form factor and sensitivity to psychological processes make it a very attractive element in the user experience tool belt. EDA has been used in different areas at SIGCHI, such as games, learning, VR, arts, usability, and interface design, and suggests wide applicability and rich potential for use by SIGCHI researchers. Despite its ostensible simplicity, recording and analyzing EDA signal is a delicate and often intricate undertaking involving knowledge from psychology, physiology, and signal processing. The underlying psychophysiological mechanism of EDA is complex and not well understood, leaving various factors unnoticed that potentially affect the signal. This context created severe risk for SIGCHI researchers to build their research upon a field outside of their expertise, threatening the validity of their results. Therefore, in our paper, A Critique of Electrodermal Activity Practices at SIGCHI, we conducted a systematic review to assess and improve quality of SIGCHI studies involving the use of electrodermal activity data and drive recommendations for future works. Our results highlight the concerning issues in different aspects of SIGCHI EDA practices, namely devices, participants and external factors, psychological constructs, pretreatments and controls, and analysis. Our results emphasize the dire need for improved community standards for EDA practices at SIGCHI. The main concerns that our result highlighted are threefold. First, based on our review, it was not always clear whether internal validity had been preserved, as procedure descriptions were often limited. For instance, only a few papers reported details on how devices were worn, and the same issue prevailed in how controls were performed before and during the studies. Furthermore, several papers in our sample used sites on a skin of which changes in conductivity are not representative of sympathetic nervous system processes. In addition, many EDA practices at SIGCHI involve intense physical activity, which risk EDA recording quality by destabilizing electrodes and increasing body heat. Second, in terms of replicability, in several cases, descriptions and methods were not comprehensible due to selective, incomplete, and non-standard presentation of information. In most papers, we could not find information on EDA devices, participants' details, procedures, signal processing, and analysis. In addition, violation of a standard terminology using self-defined terms for EDA parameters and confusion between parameters made understanding papers cumbersome and in some cases impossible for reader. Third, to ensure high-quality EDA data, different treatments must be applied on the skin or electrodes prior to the recording, and several external factors must be controlled during the recording. In ambulatory recording used for in situ studies, some of these steps may be skipped due to the limited control on participants and their environment. However, laboratory studies should adhere to all of these steps as much as possible. Although the majority of EDA studies at SIGCHI were conducted in a lab setting, there is an ongoing trend toward ambulatory recording which affects the choice of pretreatment devices and controls. In addition, despite the importance of data pre-processing and signal parameterization in the analysis of EDA data, we identified a concerning pattern among the papers in our sample of using raw values directly. The meaningful parts of EDA data are the phasic and tonic EDA components, so it's necessary to isolate them before analyzing the data. To leverage community standards for EDA practices, we have developed an initial set of guidelines published at edaguidelines.github.io. and invite the community to contribute their standards and best practices according to various needs that arise in SIGCHI practice and research. We also recommend reviewers and authors to visit the codebook we developed to assess EDA studies in our paper. And eventually, if you want to know more about our review or EDA in general, please visit our paper, A Critique of Electrodermal Activity Practices at SIGCHI.